So now we know that for cos theta, the angle is 1 minus theta squared over 2. Now, if we use that, then we are just applying it to cos 3x, okay? So cos 3x will become 1 minus 3x squared. Don't forget to square the 3 here, okay? So over 2, right? And that turns into 1 minus 9x squared over 2. Now, because that's squared as well, you have to basically square this as well. So this whole thing is going to square out. Now, we'll deal with the second bracket, like second thing later. Let's expand this. So you will have 1 plus 81 over 4x to the power of 4 minus, when you obviously expand out the middle terms, the 2 should cancel out, right? So you're going to get minus 9x squared, okay? And that's basically your expansion done, okay? Now, because the angles are small, I know I should have mentioned in the question, because the angles are small, you would ignore this term, okay? Ignore this term and ignore this term as basically angles are small, okay? So you are basically left with an approximation of 1 minus 9x squared, okay? So that's what it reduces to. And that's just cos squared 3x, okay? So now if I apply everything, I also know that sine theta is approximated to just theta, okay? So then sine 3x over 4 will become simply 3x over 4, yes? So now from here now, I will just simplify this out. So I've got 1 minus 9x squared for the front bit. So 1 minus 9x squared. And then I've got minus 1. Okay, so put that there, which cancels out nicely. And then I've got 2x. Okay, so I'll just use a bracket. So 2x, then I've got basically this as 3x over 4. Okay, and now to simplify this further, this basically becomes minus 9x squared times by, this cancels out into 3 over 2x squared. Okay, so 3x squared over 2, which then further simplifies to minus 27x to the power of 4 over 2. So that should be the answer. Nicole, is that what you did?
I didn't square the cos thing.
It is such a common mistake. I think I've seen, like, I did not read the forum where the student had posted this question properly because I was like, I want to try it, you know. So I don't know what the final answer, if the student knew what the final answer was, but this is my answer, and I hope it makes sense.
So this was an A-level paper?
I don't know, Smriti, because it was just posted randomly. Yeah, no idea. But it is indeed, I think, rather than 3 marks, because I just basically guessed it, I'd say maybe 4 marks. 4 marks, max 4 marks. So that's basically that question, number 1, done.
What did you think of paper 1?
I haven't actually had a look because I've been very busy.
Yeah.
I will have a look, to be honest. I really want to, but yeah, I need time because I want to do the questions myself. So especially the integration question, because thank you for sending me the paper. I don't want to look at it right now unless you want me to look at it. Okay, no. Okay. So let's move on, guys, to the next question.
I just don't know where the 225 went.
Yeah. So this question is basically on modeling with differentiation, I'd say. Part C, right? A kind of question has come up before, and I remember it was in terms of N, and it took my breath away. Like, I did a 15 minutes video on YouTube on that question, because every single time I've given it to any of my students, nobody has been able to do that question. But this one is rather slightly simpler. Okay, so I will go through this. Let's start with the first part. So we've got theta, which is the temperature of the oven. T minutes after it has been switched on, state the highest temperature of the oven according to this model. Now, you can see, right, that this is a negative, okay, exponential curve, right? So the maximum temperature is going to be 225 degrees Celsius, okay? Because as T, okay, is basically, you can imagine like a curve, right? And you would imagine that if you have a negative like exponential curve, right, the maximum value of the temperature is going to be at the start, okay? And so 225 is the answer here. Now, alternatively, if you really want a full explanation on that, you can also see that if, right, e to the minus 0.1 t tends to 0, okay, you will see that this whole thing will become 0, and therefore theta is equal to 225.
Oh, I literally subbed in 0 for t and then I got 25.
Yeah. Because if you sub in t as 0, you will get 200, right?
I got 25.
Yeah, and then 225 minus 200.
Yeah.
Is that what you did, Nicole?
No.
No? Did you get 225? Okay, good.
I just said a really big number.
Fair enough. That's basically what you can do, because you know it's a decrease, right? So as you go along like a really big number, it would basically become 0. Okay, it would become minute. So that's basically what you have to consider. Okay, now for part B, we have to determine the value of the temperature, the value of T when the oven reaches 125 degrees Celsius. So that's easy, right? That's just, you just have to put that in the equation. So 125 is equal to 225 minus 200 e to the minus 0.1 t, okay? So then you take away 225, okay, and then divide by 200, and you will be able to then learn both sides. So you end up basically getting 100 equals 200 e to the minus 0.1 t when you clear out the negatives, right? And then it will be 1 over 2, okay, you can learn both sides here, is equal to minus 0.1 t, okay? And because ln is like 1 over 2, it will be a negative number, okay? I think it's 0.693. I know this from physics. I don't know how. I think that's that, but yeah. Pop it in the calculator, and it gives you time as, well, 6.93. Yay! Okay, something. And if you want to round it, you can say 7 minutes approximately is the time taken for the oven to get down to 125 degrees C.
But you get the mark for 6.9.
Absolutely, yes. Now, for part C, we have to show clearly that d theta over dt is equal to that. Now, differentiation is really simple, right? Mm-hmm. So d theta, so if I just do that over here, d theta over dt is going to be 20 e to the minus 0.1 t. Is that right?
Oh, and literally just differentiating.
Yeah,
I think that's what I got at first, but then I didn't know how to get it into that form.
So that's basically what you get, right? Now, from here is a little bit of a, how do I get it in terms of theta, right? So you have to look at the original equation. So because you know that theta is in the form of that, I promise you guys it's easier than you think, okay? So what I would do is I would manipulate this equation, the given equation, to have it in terms of e. Okay, like I would make e to the power of minus 0.1 t the subject. So let's do that, right? So you have let me just make it positive because I really don't like the negatives. Okay, so negative t is equal to 225 minus theta, yes? Now, I can, because I want 20, okay, e to the minus 0.1 t, I'm just going to divide everything by 10, okay, in this equation here, okay? So if I divide everything by 10, I am already one step closer to my answer, right? Because it's 1 over 10 in there. So I get 20 e minus 0.1 t equals, I can just put it as 1 over 10 to 25 minus theta. And here you go. That's your answer, isn't it? That, yes, Ari?
How do you, like, connect the second bit to that bit? Like, how does that show that, like...
So, Ari,
like
you
the
just...
rate bit, is that, like, you do that separately?
What? Sorry, I didn't catch your
As in,
question.
hence find the rate at which the
Oh,
temperature
I
is
haven't even looked at that
Sorry.
yet. Yeah, no. Give me a second.
Sorry.
No. So that's basically part, sort of showing that d theta is in the form of theta. Okay. Now, is that clear to you girls? Yes? Okay. Let's move on to the next part where it says, hence find the rate at which the temperature of the oven is increasing when its temperature has reached 125 degrees C. Well, that's easy, right? So you know that theta is equal to 125 degrees C. You're finding d theta over dt, yes? Because it says find the rate at which the temperature is increasing. So it will be a positive answer.
So you sub it in?
Yeah, you just sub in theta as 125 degrees.
Wait,
okay.
so you could have done that without...
Indeed, yes.
Oh.
So that's the good thing about maths, right? Because you can do, if you read them carefully and not get disheartened by, oh my God, I can't do this first question. Look at the second one, you might be able to do it. Okay.
Marks do you think you would get if you just put it into the original formula and got the rate at which the temperature was increasing and didn't do the...
I reckon you will get only 1 mark because it's very straightforward, right?
Yeah,
It's a calculative step. So d theta over dt is 1 over 10 to 25 minus 125. And that basically gives you 10 degrees Celsius. Yes, indeed. Yeah, 10 degrees Celsius per minute. Okay, so I hope they don't cancel marks for the incorrect unit because it is a rate, okay, of increase. I don't think so, but just be watchful. Okay, so that's question.
I actually hope this comes to the test.
Yeah, guys. I'm not taking any responsibility for that. Okay, so let's move on to the next question now. Here we are with question number 52. Now, you guys said that this question was easy except Nicole. Nicole, I actually agree with you. You're like, where do I start? Right?
Yeah, that's what I got confused on.
I know. Guys, it's really hard to start with the first, like the given equation. That's the problem. So I would manipulate the second equation and make it look into the first equation. Like I would find the value of x. And I would show, right, that the value of x is going to be this, okay? Because that's an easy part to do. Okay, so what do you do, Arya, over here? Starting point?
Starting point. Literally from that equation, I divided everything by 3 and then learned both sides. So that x was on, I made x the subject from the e. I did not do that.
Okay, so did you, right, so this is what I'm assuming you did. So 2 equals 3 times e to the minus x over 3x. Is that what you did?
I calculated it wrong. This is what I looked at.
Oh, right. So you I see. Okay, right. Interesting. Okay, I got you. Okay, so you did. Okay, so I'm gonna just consider that because why not? Okay. So you did 2 times 3 to the x over 3 equals e to the minus x, right? Okay. Now from here you did ln. Okay, right. So, okay. All right. So you have to be careful, Arya, because when it's correct. So if you ln both sides, you'll have ln of 2 times 3x over 3, and that'll be minus x, right? Minus x. Okay. What will be your next step?
Then I split the fraction in the ln into ln of 2 times 3 to the x.
Yeah.
Minus ln 3.
Okay, correct. Okay. All right, so ln of, I'll just leave that bracket as it is, minus ln of 3 equals minus x. Okay, I agree. Then?
I don't know if this is correct. This is the step I wasn't sure about. But then I split ln 2 times 3x into ln 2 plus ln 3x.
Correct. Yeah.
The x to the front.
Yeah. I completely agree with you. That is the way to go. Well done. So you will have something like this. So Smriti, over here, this is just one of the ways in which you can do it. I would have just basically, ln everything.
That's
like,
right.
Yeah. So we are absolutely fine either way.
Yeah.
Okay, so with this now, x comes forward. Okay, so I would get ln 2 plus x ln 3 minus ln 3 equals minus x. Now from here, it's easy peasy, right? You just basically move the x's on one side. Okay, so I've got ln 2 minus ln 3 equals, oh, I've got two negatives, right? Can I make, okay, I'll just do it in the next step. So I've basically got that. Now, because I've got two negatives and I don't like negatives, I'm going to just multiply everything by -1. Okay, so as to make everything nice and simple. So now from here, I would divide both the sides by, obviously, factorize that bit. Okay, so x, that would have become 1 plus ln 3, right? And then divide that. And here is my answer. I wish this question comes up. Given that it was relatively simple, there were not too many ln questions, right, in the first paper.
There was none. I don't think there was
none. Yeah. I did some research and I found out the topics which were not there, as you guys said. The topics. Yeah.
Rates of change.
We're gonna look at some parametrics as well. Yes.
If we have time, could we look at a vectors question?
Vectors wasn't in it.
Yes.
One of the,
yes,
like,
that was
maths
one
teachers I wrote for
problem. I
as
didn't
far as
have
I
time
can
to find you a vectors question, but yes, we will. Okay, hopefully. All right, let's move on to the next question. So with this question, you're given the equation of the curve, and we need to show that the gradient of the curve at point P is that. So, well, we got to work out dy by dx implicitly, and we have a couple of things. Okay, so there's, first of all, x times y. So what are we going to do over here with dy by dx? But
Whatever it's called,
product.
Yeah.
Product rule. Yes.
Differentiation by parts.
Differentiate. You wish. Product rule. Yes. I know what you mean though, because I know
That's
it
fine.
looks like times. Yeah. Okay. Thank goodness. Okay. She did not do it by parts. Okay. So that's that. And then with respect to 3 to the y, that's where you guys had issue. Remember that differentiation of a to the power of x is a to the power of x ln a. Yes, this one, I believe, is given to you in the exam.
That's what I tried to do with it, but
Yeah.
I didn't know how to do it.
Don't worry, I got you. So here, right, let's start with everything. Let's start with differentiating 4x cubed. Okay, so you end up getting, I'm just going to change the color. So that will be 12x squared. Okay, as simple as that. Now minus, so if you're not confident, do it separately. Okay, if you're confident, whack it in like straight away. Okay, so you know that there's -6. Okay, -6, leave it alone. All right, then differentiate x. Okay, so x differentiation is just 1. Okay, so it just disappears and you get -6y. Then you have again a -6. Okay, and then you differentiate y. Okay, leave the x alone. Okay, what do you get when you differentiate y implicitly? Dy by dx, yes. So you get dy by dx. Okay, now with respect to 3y, fear not, right? Because you just have to differentiate it as normally, as if it was like x. Okay, so imagine if it was 3 to the power of x. It will be just 3 to the x ln 3, right? So this is 3 to the y ln 3, okay, ln 3 dy over dx. That's it. That's the only extra, right? Because you're differentiating y.
What if that's 4 to the 2y? Or is that not possible?
No, we don't talk about Bruno.
Oh.
No, we won't get that. Okay. I mean, if we do get it, then it would be like, I hope not, but it's just going to be chain rule. Okay, it'll be just chain rule. So if it was like, so for example, 4 to the 2y, right? The 2 will come in the front. Okay, it will be 4 to the 2y. The power will not get taken away. And then ln of 4.
It's like e to the y.
Yeah, it's like e to the y. Yeah, very much like that. Okay, so now from here, we will collect all the like terms, right? So we have 12x squared minus 6y equals, I'm going to just move everything else to the other side. So I will have 6x dy by dx. Or rather, you know what? I'm just going to factorize it as well. Okay, so honestly, I've got the smallest rubber on this. Okay, so I would factorize that. So 6x, okay, minus 3y ln 3, okay, and then dy by dx. Okay, so that's that. And now I would divide everything by the brackets. So dy over dx is equal to 12x squared minus 6y over 6x minus 3y ln 3. So now at this point, or previously, right, you may have put the value of x and y as 2 and 3 respectively. Okay, so now at P, that's your final step, okay, final stage, 2, 3, right? So you have got your dy over dx as 12 times 2 squared minus 6 times 3 over 6 times 2 minus 3 to the power of 3 ln 3. Obviously, you're expected to leave the ln 3 alone. Okay, so what do we have? We have 12 times 4, okay, 48, minus 18. Okay, so that will be, okay, 1 second. So I'm just going to put that down, 48 minus 18, so 30. And at the bottom, we have 12 minus 27 ln 3. Okay, so let's just move right here. So we've got 30 at the top over 12 minus 27 ln 3. Now, what do we do as the next step, guys?
Divide by 2.
Divide by 3, okay. So I end up getting 10 over 4 minus 9 ln 3, where k is 4. K is 10. Sorry. Okay, k is 10. Okay, so that is basically done. What a beautiful question. Again, if you know how to do it. Yes, definitely, yeah. But that's the point of these questions, guys. This is the point of this lesson. I want you to be able to do questions like this. Hopefully, nothing harder than this will come up, but you never know. There's always going to be 1 or 2 questions which are hard. Okay, so let's move on to our next question. Now, with this question, we're given that oil leaking from a damaged tanker is forming a circular oil spillage on the surface of the sea, whose air, like, who cares? Sorry. I know.
Oil in the sea.
Okay, so we are given that the the area is increasing at a constant rate. Okay, so we're basically given here dA, if A is the area, circular area, over dt is 360 meters squared per second. Now, further, we're given that we may assume that the spillage is of negligible thickness. Find the rate at which the radius of the oil spillage is increasing when the radius of the spillage reaches 100 meters. So there's a lot of words. Okay, let's summarize what they're asking for. So the rate of the radius increasing. Okay, so what they're asking for is therefore dr over dt. So what is that? At r equals 100 meters. That's basically the statement, yes.
You know, it says we may assume. Is that part needed?
You can, so basically what they're saying is that the thickness is, so if you can imagine like a spillage, right? And it forms like a blob on the surface, okay? So they're just saying that the blob, like that, so like, let's say this is the water surface. So, and then this is like this is a circular area. They're saying that just ignore how thick the water, the circular, the oil is, yeah, because you would then have to consider, the surface area differently. Like it will be almost cylindrical.
So if it said stated limitation of
Yeah, that would be a very good limitation because you know that the oil is going to be more like a sphere rather than a circle. So that's why they are basically ignoring that. And if it was really thick, okay, it would be more of a cylindrical shape. So yeah, don't have to worry about that. Yes.
If you did take thickness into account, would the rate that the radius increases be slower or faster?
It would be slower.
Slower.
Yeah, because it would occupy more,
It's
like
more
it would
like-
go down.
yeah.
It would be smaller.
Yeah.
Yeah.
Okay. I thought so.
Okay, so now let's look at this. So how do we start with this question, guys? What we do is we look at the basic formulae and we look at the connections, like obviously connected rates, right? So we're given dr over dt. Okay, I mean, that's what we are trying to find. So can we rewrite dr over dt somehow in terms of a?
Yeah.
Yes, exactly. So dr comes at the top, followed by dt should come at the bottom. Okay, if we want dA, because dA over dt is given to us, which is nice, we must have dA at the bottom. Now, therefore, I need a connection between the area of a circle and the radius, which we all know is pi r squared. Okay, so if area of a circle is pi r squared, what is dA over dr?
2 pi r.
2 pi r. So now whack it in, right? Let's see what we get.
2 pi r.
Okay, so we flip it, right? So we have, sorry, Smithy, you were saying something?
Just half.
Oh, okay. Yes, half like that, and then pi r with it, and then dA over dt is 360, okay, and r is 100, so put that in, so 360 over 2 pi 100, and that ends up basically giving me 9 over 5 pi, or 0.573 meters per second.
Can I leave as 9.5 pi r?
Yes, you
Pi.
can. Yes, you can.
Is this like still or not?
Yeah, because this question, honestly, would be around 3 marks.
Oh.
Okay, because there's 1 mark for dA over dr. Okay, then there's 1 mark for the equation of the connected rates. Maybe max 4. But that's like just really pulling it. So that's basically 3 to 4 marks ish. Okay. Now, are we good to move on to part B? So it says determine the rate at which the radius of the oil spillage is increasing 1 minute after it started forming. Now that's the tricky part because we are given the time. Okay, 1 minute. So please immediately think about it in seconds. Okay, because the rate is given in seconds. Yes. So we have to find out what is, so at t as 60 seconds, we need to find out what is dr over dt. Okay, now, well, we already have an equation, a general equation of dr over dt, which is obviously this 360 over 2 pi r, or 180 over pi r. Okay, so what does that mean? That means that we need to find out the radius, yes? We need to find out the radius after 60 seconds. Now, we have to assume over here that the rate is constant. Okay, so we are given 360 meters squared per second. All right, so this part is a little bit tricky. Okay, so, well, I say tricky, it's just long. Okay, so if rate is of the area, okay, dA over dt, okay, which is 360 meters squared per second, can I get the area in 60 seconds?
That's what I divided it by 60
Absolutely.
for the area.
Okay.
I don't know if you're allowed to do it that way.
Yes, you are.
Okay.
Yes, you are. So, well, you would times it by 60, no?
Oh.
Because because if you are it's very cheeky. It's almost like integration,
That's nice.
Really?
right? Because if you have dA, if you have dA over dt, then you are basically doing integration of both sides. This is just like a side note. Okay, so if you integrate both sides, you would end up getting like this, right? Okay, and when you integrate 1 with respect to dA, you get A. Okay, and when you integrate 1 with respect to t, you get 360t, okay? And of course you have plus c, okay? And we are just basically sort of assuming that area was 0 at t equals 0, you know, and so c is 0. So we kind of like ignore that fact, and we just assume that area is therefore 360 times t. Okay, so that's like the maxi part behind it. Okay, exaggerated part behind it. So now 360, therefore, times by 60, okay, is how much?
21,600.
I knew that. Sorry. Yeah, I mean, I kind of knew that, but oh well. Okay, so this is now the area of...
And that's pi r squared is equal to that.
Exactly. So we can find out what r is, right?
Pi square root.
So now r is therefore 21600 divided by pi, and then square root that answer. You end up getting 82.91 something. Is that what you get, Aria?
I didn't get that far, sorry.
Okay. So if that's the radius now, we can work out what dr over dt is.
Hey, do you not need r?
Yes, you do.
Which the radius?
Yeah, so you need to put this radius back into dr over dt. So I think this is a end of paper question, okay? Because it is so marvelous, okay? Sorry, guys. It's really nice, okay? It's one of the things where you will have to think about. So anyway, final answer when you plug it into dr over dt. At r equals 82.9 ... Obviously, you're not rounding until the end. Okay, so it will give you just gonna reduce it to 180 pi over 82.9 ... And that ends up giving you 0.69. Ugly numbers, but yeah.
I'm just confused.
Yes.
You guys said 1 minute.
Yes.
When did you use that information?
60 seconds, right?
Yeah. So you did 3. So first you just do the differential equations.
Yeah, I just basically I did extra work. I didn't have to do differential equation. I just have to assume that the rate is constant.
Yeah.
Okay. So therefore, in 1 second, like you just basically, 360 meters squared per second, right? Yeah. So in 1 second, it'll be 360 meters squared. In 2 seconds, it'll be, twice that. So I just multiplied 360 by the time.
So you can go straight into it.
Yes, you can. Yeah, you don't have to do all that jazz.
Yes.
Okay. Assuming that you write down that the rate is in constant.
Oh, so then you just do pi r squared stuff.
Yeah, absolutely. Okay, right, let's move on to the next question now. Okay, let's talk about this one. So we are given a curve, a cubic curve, and we are given fx in the form of a, b, and c, when we need to basically work out the values of a, b, and c. So as you guys know, the roots are already given to you. They are cubic. So because this point over here is touching the x-axis, not crossing the x-axis, it's a repeat root. Okay, when it comes to repeat roots, okay, and you already know basically this is the other root, okay, this one is going to be squared. Okay, so you can say that fx is essentially x minus 1 squared followed by x plus 3. And then you just expand. Yeah, right. So, Nicole, is that what you did as well?
No, but in my defense, it was like getting late. And
Okay.
it wasn't functioning properly.
Fair enough.
I forgot you can do that.
Okay, but you understand this, yes? Okay, perfect. So once you got to expanding stage, you end up further expanding and you get a cubic term, which is just like before, and then I'm just gonna basically tidy this up. So plus x squared minus 5x plus 3. So your a is therefore 1, b is minus 5, and c is 3. Okay, so that's that. But a done. I'd say it would be worth 2 marks only. Okay, I mean, I would be very happy if it's 3 marks for like 1 mark for each point, but it's relatively simple. Okay, so now part B is asking us to sketch the graph of 1/3 x. You know, I never see 1/3, like I never see fractions in the brackets. Indeed, indeed. So clearly marking the coordinates of any point of intersection with the coordinate axes. Okay, so guys, what we know is we know that this point now on the y-axis originally is going to be 3, right? Yes. So that's going to be 0, 3. Okay, and now let's plot that graph. Let's sketch that graph. So it would just expand. The y-axis will not change. So this point is going to be -9, 0. This will be 3, 0, followed by 0, 3. Okay, did you guys get that? Yeah?
I got it wrong in every way imaginable.
Why?
No, graph. I think I just need to go over graph transformations like questions.
Yes,
I think that's
it's
just a
year
weak
1
point for me.
concept. Yes,
Yeah.
year 12 concept. So please do.
Potentially not gone over
Yes.
it enough because I'm like,
Also, guys, you know, this lesson, what you could do is make a note, as Ira said, you can make a note of what things you need working on, okay? Because you have time, okay? So now let's talk about part C. It said the graph C is translated by a vector -1, 1 to give a graph of gx. Show that gx is that. Well, easy. How? Well, just manipulate the equation, right? You have fx equation. So if you have -x along the x-axis, your bracket should, okay, so I'm just going to put it as, so what I'm going to do is I'm going to put it as f, okay, x, because I'm going, well, you know what, I'm just going to call it gx. It's just easy that way because I know what I'm doing in terms of the brackets. So gx is equal to, you insert, okay, x plus 1 into the brackets, okay? And I know it's a lot of expansion and tiding, but that's the easy part. Okay, so 1 followed by 3. And then don't forget that along the y-axis, there's a change as well. It's moving up by 1 unit. So you must have plus 1 as well. Okay, Ara's smiling.
I got it the right way round.
Yay, okay.
I almost like minus both.
Okay, so guys, I have a little trick over here, okay? Instead of expanding the cubic, which is hefty, okay, what I would suggest is, obviously 3 plus 1 is 4, you know, let it be, okay? Now, if you look at this whole shebang, okay, you will notice that x plus 1 is common, yes? Take it out, factorize it. So x plus 1, okay, outside the brackets, okay, what are you left with for the first bracket?
X plus 1 squared.
X plus 1 squared, indeed. It reduces your work. Okay, then for the second bracket,
X plus 1.
x plus 1. Then for the third bracket, minus 5, indeed. Okay, so obviously, please make sure that the 4 is still just left outside because there was nothing common there. Okay, so now, when you expand this, it's much easier. Okay, so I am going to basically do, I'm going to just write down the final answer. I mean, no, I shouldn't because the final answer is already given to me. I'm not going to get any marks for that. So x plus 1, x squared plus 1 plus 2x plus, can I just do x minus 4 here? Okay, and then I have plus 1, plus 4, my bad. Okay, and then it would become, you know guys where I'm going with this. So x squared plus 3x minus 3 and then plus 4. And then do we end up getting the answer from here? So we've got x cubed. I'm just going upwards rather than going downwards. Plus 3x squared minus 3x. I just want to make sure that I get the answer. So plus x squared plus 3x minus 3. And then I can now put plus 4 in the end because I've expanded the bracket. Okay? Yes. So x cubed, this is 3x squared plus x squared, which is 4x squared, Oh, we have a plus 4x squared, so we've gone wrong somewhere, guys.
I got that as well. When I expanded all that out, I ended up with x cubed plus 4x squared plus 7. And I tried to do do the roots of gx and figure out what bracket I was missing, but that didn't work for me. Like, that's where I got stuck, is that I didn't get the answer when I expanded it.
That's very interesting. So let me have a look. Okay. So, all right. So basically, there is an error here. According to the mark scheme, this is supposed to be squared. So now, if you've got the answer, do we have the answer? Yes, because 3x and 3x cancels out, and then you're left with plus 1. Okay, cool. Okay, so squared. Sorry, there we go. So that's done. Let's move on to the next question now. Let's start with this beauty. So we're given two parametric equations, and we need to find out the equation for C. Yay! Easy, right? Cartesian equation. So because we have lens involved here, it becomes a little bit tricky because you have to be careful. But luckily, both sides are basically lind, like singularly lind. Okay, so lind is suddenly natural logged. Okay, so Nicole, what did you do here to begin with?
I put both sides to
E. Okay, I agree. All right, so the first one will become e to the power of x is equal to 1 plus t. Okay, and what about the second one? ey. Yes, so ey, just the way you said it. Okay, so ey is equal to 1 minus t. Now, because I want to get rid of t, right, because I want to manipulate it, I'm going to add them. Exactly. Cute, right? So you just basically add them. Exactly. And so, if they were both positives, then you would take away. Okay? And you would end up getting ex plus ey is equal to 2. How easy is that? You just have to see it, though. Okay? You just have to recognize that.
I made t the subject, then made them equal to each other.
You can do that too.
Then I
absolutely fine. Okay.
Listen,
Okay. Now part B, determine in terms of natural logs the coordinates of the point on C where the gradient is -3.
differentiate.
Indeed. Okay, so we have our dx over dt. Okay, so dx over dt is equal to what, guys?
Oh, dy over dt times dt.
Dx.
No, dx over dt.
So with dx over dy. No, dx over
No. Let's differentiate. What I mean is, let's differentiate.
Literally, what's the answer? Oh my god, sorry.
Yeah, what is the answer?
Completely misunderstood you.
1 over t.
1 over t. Okay, thank you. So 1 over 1 plus that,
1 plus,
right?
yeah.
Okay. So then dy over dt similarly is going to be, what would that be?
1 over 1 minus t.
And then? No.
Ln y dy by dx.
No. You're missing something?
Oh, minus.
Minus 1 over 1 minus t. Why?
That
Because that's the coefficient of t is negative. Thank you.
Divide them by each other.
Yes, now you got to divide them by each other. So we know that dy over dx is dy over dt times by dt over dx. Okay, so then basically we have to just put them together. 1 minus 1 over 1 minus t times by, flip the first one, so it becomes t plus 1, okay, in brackets. So now I can just say in a slightly tidier way, I can say that dy by dx is equal to minus t plus 1 over 1 minus t.
And now you know what t is? Oh no.
Well, not yet.
Yeah,
The thing is, we know the gradient, right? So we are going to now find the value of t. Once we have the value of t, we're going to insert it into x and y to get it in terms of ln. Okay, so that's basically equal to -3. Okay, so we have can I just cancel the negatives, because as you know, I hate negatives. So you have t plus 1 over 1 minus t equals 3, okay, followed by t plus 1 equals 3 minus 3t, followed by 4t equals 2, so t equals a half. Okay, so now when t equals half, stick into x and y. Okay, so therefore, x is equal to ln of 1 plus a half, okay, which is just basically ln 3 over 2. And y is equal to ln 1 minus a half, which is ln half. Boom, done. How's that? Yeah, relatively simple, guys. I've seen worse questions. So the value of t is restricted between t1 and t2. Given that the interval between t1 and t2 is as large as possible, determine the value of t1 and t2. Ew. Like, what's that, brother? Sorry. So what do we do here? Nicole, what are your thoughts? It's simpler than you think, guys.
Make sure the lns aren't 0.
Absolutely. Make sure, well, ln can't be negative, right? So because for part C, right, natural log can't be negative, okay, then that means that 1 plus t must be greater than 0. And therefore, t must be greater than minus 1. That's one value. And we also know that for when ln has got 1 minus t in it, okay, 1 minus t has to be greater than 0. So then minus t is greater than minus 1, or t is less than 1. As you cancel the negatives, you flip the sign. So there you have it. T is between minus 1 and 1.
That's like 2.
Yes, 2 marks, I reckon. So I think the first part is also 2 marks. The second part is maybe 4 marks. Okay, 3 to 4 marks, and then part C will be 2 marks.
Would you have to say like minus 1 and 1?
What do you mean? As in the values of
Yeah.
T1 and T2?
Yeah.
You can, but they just give you a range in the mark scheme. Okay, right, so let's move on to the next one now. Okay, so for this one, we are given a partial fraction situation where we need to find out the values of A, B, and C. So it tells you, A, B, X plus C bit, okay, which is nice and simple. And so I'm going to just multiply out, okay, just sort out the right-hand side. So it would become A brackets 2x squared plus 1, and then bx plus c, okay, brackets 6x plus 1. Okay, so that's that. Over, obviously, the denominator. Okay, so I guess I can just put that right real quick.
Wait, do you need to put that in?
No. When you are comparing the numerators, as long as you just basically, you would put it in like this first, but then you don't have to carry it on because you're comparing the numerators then. Yeah. So what should we put? Shall we put x as what should we put x as?
I started with minus a 6. So
minus a 6. Okay, so that would cancel out. Yep, sounds good. Okay, so if x is minus a 6th, then what do we get over here, guys? So we've got a, okay, so 2, and then that will become 1 over 6 squared, so 1 over 36, or can we just say 1 over 18 plus 1? And then the b will become 0, okay? B and c, they will oh, hang on a second. Does c become 0 though?
Mine didn't become 0. It just stayed
Yeah,
C.
it shouldn't become 0 because so I think, Arya, what we should do, right, is we should just expand the second bracket first.
Oh.
Because that would avoid, that would just help us see it better as to, what value of x we should put. So the second bracket, okay, becomes 6bx squared, 6bx squared plus bx plus 6cx plus c. Okay, now that's better. Okay, so then we have, obviously a is the same, doesn't change. Now, you can use the comparing the coefficient method, and I am leaning more towards that. Can we do that? I think that would be much better because we've got quite a few letters. So what I'm going to do is also make this expand it. Yes, expand it out. So Smriti, over here, your method, the one that you got taught at school, comes handy. So we would have 2ax squared plus a. Okay, so now I'm going to collect all my x squared terms. So I would have 2a plus 6b. Okay, I've got the x squared. You guys are aware of coefficient method, right? Comparing the coefficient. Good. Okay, good. Okay, so now we've got the coefficients of x. So b plus 6cx. And then constants are just a and c, yes? Okay, cool. So that's basically that. Now I'm going to compare the coefficients. So make it very clear what you're doing. Okay, so comparing the coefficients of x squared. Okay, so we've got 2a plus 6b is equal to 12. So we can simplify that if we want to. Divide everything by b. Oh, yeah. So I'm just being extra. Okay, so that's that. And then I can do b. I mean, I would expect you guys to work this out for me in the calculator, please. We'll be much quicker. So b plus 6c is equal to what? 1, yes? And a plus c is equal to 3. So this was the coefficient of x, guys. And this is the coefficient, well, constants. Okay, so constants. In the exam, I promise I'll make it much neater and much clearer. Okay, so with the coefficients I have, a plus c is equal to 3. Okay, so if you just whack it all, I mean, to be honest, the equations are really simple. If you do this equation with this equation, number 3, and this is 2, you can work out. Okay, you can cancel out the a. Oh, you can't actually. Sorry, I just realized you can cancel out the a and then solve it with b. Okay, or whack it in the calculator as 3 unknowns, and you would end up, hopefully, what do you guys get, just to make sure that it matches the answer?
310 a plus 3.
Yeah. Yes, that's right. Perfect. So a is equal to 3, b is equal to 1, and c is equal to 0.
You know, when I did this with my teachers,
Yes.
when I did it with 3 values, they said you might not get full marks if you do 3 values in the calculator.
Oh, really?
Yeah, that's what they said. Then they said but it's 2 is fine, but 3.
I see.
So then my teacher said do the first 2, and then just do the third with the values you got.
Yeah, so that's what I was suggesting. So what you could do, okay, so sure, I mean, teachers could be right. I mean, to be honest, guys, I would, in the exam, just to be on the safe side, I'll just check.
Yeah.
I would do it myself, but check in the calculator.
Yeah.
All right, so I would do, as I said, 1 and 3 first to cancel the a's out. Okay, that way I would get an equation in terms of b and c, and then I would use the calculator further to get the second equation with it. Okay, so yeah. Okay, so we've got a, b, and c. Okay, now let's work out, the integration of that
Would
situation.
the integration part be 3 marks then?
Let's find out, Smriti. I haven't done it. Let's see. So, guys, our fraction, okay, is, it would take me a while to rub this off. How can I rub this off? Does it work if I click? I don't. Yeah, I'm not sure. Never mind. I'll just.
You need to increase the size of the pen so that then your eraser is also bigger. Okay.
Like ours.
No. It's okay. I will take a while to clear this off. I think I can probably. Oops. Hello. Scroll through. No, maybe zoom out. No, objects is locked. Okay. No, oh, clear all drawings. Okay, hello. Yes, I can do that. Okay. No, oh my God. Okay, I'm just gonna let it be. Let it rest. Okay, so 3 over 6x plus 1. Okay, I'm just putting the values of a, b, and c now. Okay, then plus b is 1. So x over 2x squared plus 1. Okay, c is 0, which is nice and simple. Okay, so we are to integrate this. Okay, so integrate this. Now I will deal with the limits later. Let's just deal with the integration itself. Okay, so what is the integration of the first bit? This 3 over 6x plus 1.
Half ln 6x plus 1.
3 ln,
All
yep.
the realizations in the same order.
Yeah.
Yep. So
5 by 6.
yes, good. I am so glad that you guys did not miss out on that. And then we have to deal with this beauty, the second one.
Reverse question rule.
Reverse question rule. Chain rule, reverse chain rule. That's what she meant.
No.
Yeah.
It is, isn't it?
Yeah.
Differentiation of absolute.
Yeah, so you want 2x squared plus 1. So you can either do reverse chain rule or you can do substitution, okay? People who, I would just let 2x squared plus 1 as u. But that's longer, okay? That is longer. I'd rather you use, if you're very confident with reverse chain rule, you use that, okay? So if I was to reverse chain rule it, I have to think about a function, which is y, okay, like let's just say, okay, such that I end up getting this this integral, right? So if I use ln of 2x squared plus 1, I would get, when I differentiate this, I would end up getting 1 over 2x squared plus 1, yes? And then I have to do 2x squared plus 1 differentiation, which gives me 4x. Okay, so 4x. So now I notice that obviously clearly there is a 4 missing from my integral. So I must divide my y with a 4. Okay, so that's how I would
Wait,
work
I
this
think
out.
you're going to do ln if it's like a square.
Well, Smriti, you can't do ln if
the
this whole thing is squared.
Oh, right.
Okay, that's when you can't do it. Okay, so otherwise, yes, you can. Yes. Okay. So now let's just proceed to putting. Bless you. Let's just proceed to putting things in order. So we basically will have half. Okay, ln. Oh my word. I really need to sort out this rubber situation or clear screen situation. It would be so much nicer with a nice clear screen. Okay, so that, and then I have plus a quarter of ln 2x squared plus 1. Okay, and then I have to basically plug in the limits 2 and 0. Okay, now guys, good thing is you don't have to neaten this out. Okay, put in your limits, and basically I'm gonna, because of the area, okay, the space restriction, I would just give you the final answer. Okay, so one can, I'm sure, put in the limits, but if you are using the calculator, please don't use the calculator to put everything in. As you know, you will get decimal places. So in the end, well, I'll just do the step before the answer. You should get half ln 13 plus half ln 3. And then you can combine this. Okay, you know that half is common. Okay, so half, and then ln, because there's a plus in the middle, you can do 13 times 3, so 39. And therefore that is your final answer, where P is half and Q is 39. Okay, just making sure that I've got everything right from the mark scheme. 3, yep. Okay, yep, that should be fine. So let's move on to the next one now. Let's do this. So this one, I think was relatively simple. The first one is asking you to prove that the left-hand side is equal to the right-hand side. So, Nicole, what would you do here?
Change tan squared x to sine squared x over cos squared x.
I agree. Is that what you girls did as well? Okay, fab. So 1 plus sine squared x over cos squared x over 1 minus sine squared x over cos squared x. And we can multiply out everything by cos squared x so as to get, I should not put that sign, so the left-hand side. And then it would become, cos squared x plus sine squared x over cos squared x minus sine squared x. Now the top becomes 1, right? Nice and simple. So 1 over cos, oh, this is so beautiful. This is so nice. I really, really hope this comes up. Okay, and this is the formula of cos 2x, exactly. And you are allowed to obviously use that directly. And 1 over cos 2x therefore becomes sec 2x. I mean, I have done some horrendous questions. This is like a piece of cake that you can eat. Okay, so part A is done. Smithy, how much do you think will be the marks? How many marks? 3. Yeah, I agree. Yeah. Okay. Part B, again, relatively simple. Okay, we have done the part of it already, so we know that sec 2x is equal. Plus 2 is equal to 0, right? So then we can just change this. So I'm just gonna do sec 2x equals minus 2, and 1 over cos 2x equals minus 2, which turns into cos 2x equals minus a half. Okay, from here I would work out the values, and I think question, I don't think it will come up. It's too easy. Okay. I know. So 2 pi over 3 is what you get. And now you are going to make sure you change the limits to double angle. So 0 to 2x to 4 pi. Okay. And you're working on with cos. Okay. So because it is, this is 120, isn't it? 60. Am I? Is it like 120 degrees? I'm just working out. I think this is a obtuse angle.
Yeah, 120.
120, right? Yeah. Okay. So I use the cast diagram, right? As you guys can use the graph method as well. And cos is basically negative, or 120 here, and it'll be here. So this and this is going to be 2 pi over 3. Okay, so you want to go like, woo. Okay, and this will be 360, or rather, 2 pi minus 2 pi over 3. Okay, so that will be your secondary value. Okay, so that will give you 6 minus 2, so 4 pi thirds.
Yep, that's right.
Okay, and then you're gonna have to also check and make sure that you're not missing out on any other value. So how do we get the rest of the value? So we've gone up to 2 pi, right? Now, what do we do next?
I used the graph, so from that I added 2 pi over 3 to 2 pi.
Okay,
2 pi plus, and then I did 4 pi minus 2 pi over 3.
Sure, okay.
All my other solutions exceeded.
Okay, so basically, either you use a graph or you use a cast diagram, you end up getting, 4 values altogether. Okay, so I'm just going to write it in terms of x. Okay, just the final answer, because I think everyone is comfortable with this. So I have to divide all my answers by 2 in the end. Okay, so x is therefore pi over 3 for 2 pi thirds. Okay, then it will be 2 pi over 3 for 4 pi thirds. Then it will be 4 pi over 3 for 8 pi thirds. And it would be 5 pi over 3 for 10 pi thirds. Okay, so those are your answers. Relatively simple. I reckon worth 4 marks. Okay, so well done for getting this. Let's move on to the next one. All right, so this one, I know I did this on TikTok, but let me explain this properly. First one, you have to calculate the two missing values in the table. Well, you just basically have to look at the width of each, sort of strip. Yeah. So if I, for example, either did this, if I did this number minus this number, okay, I would basically end up getting, so I'll just do it over here. So 7 pi over 24 minus pi over 4. What do I get? Times this by 6, times this by 6. So pi over 24. Okay, so that's the difference between the strips. So I'm going to therefore add pi over 24 to my first value of pi over 6. And what do I get?
4.1112.
No, for the value of x, sorry.
Oh, sorry. 5 over 24 pi.
Yes, so 5 pi over 24. And the corresponding, so I just put the value of x into my calculator, as in terms of the function, given function, and I get 4.1120. Okay, so is that what you guys got? Okay.
The rest are only up to like 4 though, so only did up to 4.
4 decimal
Yeah,
places.
I've got 4 decimal places too.
Because the last one's like, it's 5 significant figures, but it's 4 decimal places.
Yes.
Oh, do
Yeah.
you need 5 sig figs?
Well, if in the calculator, it's not 5 sig figs, it's more 4 decimal places, Smitty, over here. So I would put
I got
everything.
3 ones. What? I have 4.111.
It is 3 ones in the actual thing, but like when you, because it's 411197, when you do it to 4, you have to like round and then it becomes 20.
Okay.
Thank you. No.
All right, guys. So now part B. So this will be worth 2 marks. Okay, 1 mark for this, 1 mark for this. Trapezium rule with all the given values in the table to find an estimate for that. So the trapezium rule is given to you, okay, and it is half basically b minus a over n, where n is the number of strips, and then you do y naught yn plus 2 times the sum of the middle y terms. Okay, so that's basically really simple. You plug it all in. Just to be clear, b is pi over 3 and a is pi over 6. You divide it by the number of strips, so 1, 2, 3, 4. You basically get pi over 24, which is the difference. Okay, it's the thickness, right? So it is, you can, like if you know the difference, you can just use that straight away. So half times pi over 24. Okay, you put all your values in the middle and you end up getting an answer of 3.545. Okay, is that what you guys got? What happened?
I think I went wrong somewhere.
Could it be did you get these 2 values right?
Yeah.
Okay, try see if you get it correct now. Maybe you put something into the calculator wrong. Check. Part C, guys. I haven't seen much integration to do with trig identities. Okay, so there's a very likely chance that this could come up in the exam. Okay, trig identities. So what I would do is expand the brackets, okay, to integrate. And as I know I cannot just integrate it the way it is. Okay, I can't use question rule. Sorry, pulling your leg. And so I would just expand 1 plus sine squared x plus 2 sine x. And then I would have cos squared x. Okay, there's no need to change the limits or anything. Now what would I do here, guys, actually, before I answer it? What would you do? I know, minus Smitty. Sorry, Smitty. You can't answer that question.
I tried a lot of things. None of them really got me anywhere.
Okay, all right. So what I would do here is break it into chunks, like break it into pieces, okay? So you have 1 over cos squared x plus sine squared x over cos squared x. You can do that because you don't have a +1 in the denominator. Okay, so it's easy to simplify. And then you have this bit, which is 2 sine x over cos x Okay, because you have cos squared x, I can rewrite this into that. Okay, now, yeah, because it's cos squared x at the bottom, right? So I can split this up into sine x over cos x, which becomes tan x.
Yeah.
Okay, and 1 over cos x.
Tan x, sec x.
Mm-hmm.
And is that an
Indeed.
That's an idea.
You
It's
can
not
integrate
identity,
that.
You get the integration.
Yeah, you can. Yeah,
Tan
you.
x sec x.
Yeah,
I think so.
Yeah,
you
sec
get
x.
you
Yeah.
get the what
Well, do
differentiates that,
check,
and then
but
you-
I'm pretty sure.
I'm pretty sure I've
confident.
seen tan
Yeah.
x sec x in the formula book.
So this will become tan squared x. Okay, and this will become, well, sec squared x. And again, we can integrate that.
Yeah.
Okay, but we can't integrate tan squared x, guys. What do we do here?
Sine squared x over cos.
Can't do that because that's what we
Yeah.
came out from.
Oh, 1 plus sec squared x.
Yes, I mean sec squared
Yeah,
x
x
minus 1.
Yeah.
Good. Okay, so I'm going to do that. So I'm going to just leave the sec squared x the way it is. Okay, then tan squared x is sec squared x minus 1. Okay, so sec squared x minus 1. And then I've got the plus 2 tan x sec x. And, well, those 2 sec squared x becomes 2 sec squared x. Okay, so 2 sec squared x minus 1 plus 2 tan x.
You know the 2 tan x sec x? Do you do that by part?
No, tan x sec x.
Yeah.
No.
You just do tan x integrate sec x.
Is it not given to you?
I
Is
think
it
there's
one
something
single-
in the formula. I think that might be. It might be under.
It's not like one straight line.
Right.
There's a
there
sec
isn't. There's sec x tan x.
Yeah. What? That's differentiation.
I think
Yeah,
that's
but you can like you
so
can like
yeah. So
reverse it,
basically, right? Because
like if you're trying to integrate sec x tan x, then
Yeah.
you can look at what differentiates that.
Oh my
So,
God.
like,
absolutely,
Do you know what I
Just
mean?
sec-
she is absolutely right.
Oh.
Yeah. So because you know that the differentiation of sec
Yeah.
is tan x sec x, you can just reverse
Yeah.
it, and you do not have to explain yourself.
Yeah.
You know, you do not have to prove it.
Mhm.
Okay. So here, right? If I now start integrating everything, I would get tan x. Integration of 1 is just x. Okay, and then 2 sec x. Okay, and now I would stick in my limits. And when I do that, I would do it one by one in the calculator because I need to get an exact value of the integral. And that, can I just cut the steps down? Yeah. Well, you guys all know how to insert the limits because we only have very limited time. So we have 4 minus pi over 6 as the answer. Okay. If you're not confident, right, inserting the limits, plugging it in, please do try. Okay. Yes, Ari.
Can I take a picture?
Absolutely. Yeah. I mean, this will be, hopefully, if everything goes well, this will be online. Yeah. But yeah, you have the picture.
Thank you.
Okay, righty. So let's move on to the next one now. All right, guys. So this, again, integration. We can never get enough of integration, honestly.
There was one like this in the exam.
Oh, was it?
Yeah.
Yeah. So hopefully, it is likely that it won't come up, but still, practice makes man perfect, or women perfect. So now we need to just simply integrate this between 1 and e squared, and let's start with just putting it in first into our integral. So 1 e squared. I hope something, well, I guess this is really simple, right? So by parts is the name of the game. Okay, so the first one, 8x, can easily be integrated, right? So I'm just going to put that aside. So 1 e squared, 8x, and then let's just focus our attention on 4x ln x dx. So what should be my value of u? Ln x, absolutely, yeah. So remember the late rule, right? I think Smriti remembers it really well. So because we have logs, you choose u to be logs because they can't be integrated. Okay, so u is ln x, and therefore u dash is 1 over x. then v dash is, well, either 4x or x. It's up to you. I'll just use 4x. Okay, so integrating that will give me 2x squared. Okay, so now I put everything into the integral carefully, bearing in mind that there's a negative sign, 1e squared, and then I'm just going to integrate that so it will become, actually, you know what? No, I've changed my mind. I'll just do it. I'll just input all the limits right at the end.
Wait, I have a question.
Yes.
So what I was doing was, I did area triangle and then I did area this. So because I was doing area this, I used 0. So like 0 to be 2, then I would take that away.
I see, but Shruti, you're given just the
limits for the area itself.
You're given the curve, right? You're given the limits for the curve.
Yeah.
And besides, this bit, is not a triangle. It is a curve.
Yeah.
Okay, so I wouldn't worry
So
about
it's
that
just 1
section.
to 2.
1 to e squared. Yeah, absolutely. Yeah. Okay. So now I've got the 8x and then e squared 1, and then sorry. Oh, I haven't. My bad. I haven't integrated this yet. Sorry. So that will be 4x squared. And then I have this by parts situation. So again, u times v. So 2x squared ln x. Okay, e squared 1. And then integration of 1 to e squared of u dash times v. Okay, u dash, just to be clear, u dash times v. Okay, can we simplify? Yes? Okay, so x and x gets cancelled, leaving you with 2x. So you're basically integrating 2x with respect to x. Is that clear, guys? Yeah? Okay. So now, your final bit, okay, before you insert all the limits, is 4x squared minus 2x squared ln of x minus x squared. Okay, so e squared 1, okay, like so. Do you guys agree? Is that what we get? Yeah? Okay. Now, let's put the limits in. So I will do this part because I think it's with e squared, and because x is squared, e becomes to the power of 4. Then minus 2e to the power of 4 ln e squared, which I will deal with, and then minus e to the power of 4. Okay, that's e squared done. Now, minus the limit of 1. Okay, so minus, now feel free to use brackets if you're not confident, okay? I'm just gonna do it in one go because of time constraints. So 1 goes into x, so 4 minus, now ln 1, right? You know what, I'm gonna just write it down. Yeah, it's 0 indeed, yeah. So minus, sorry, it will become plus over here, my bad. Okay, that's what I mean, you know, like you can go wrong when you're doing it in a rush, so be careful. So plus, again, 1. Okay, so here we will have, to simplify this a little bit, so 4e to the 4 minus e to the 4 becomes 3 e to the 4, right? So these two numbers simplify. Then ln 1 is anyway 0, it goes to hell. Okay, so what is ln e squared, guys? 2, exactly. So 2, right, multiplies with the 2 over here, so it becomes minus 4 e4. Okay, and then you have minus 4 plus 1, which is minus 3. And so your answer would be minus e to the 4 minus 3, which is really odd. I have done something wrong. Let's see. Where have I gone wrong? So, I'm just gonna. All right, so I found the mistake. The mistake is actually quite a silly billy mistake. I've got a negative here, right? Yeah. So then I was dealing with the integration of this right here. So that means that if I had a negative down there, right, the second term the integration will become positive. Okay, that is so silly of me. Okay, so this will therefore become x squared, positive x squared. Okay, so let's fix that. So this bit, oops, it's not gonna let me rub. Okay, so this will become a positive x squared, and then this will become negative right here. Am I right?
Yeah.
Yep. Okay, so I would end up getting -5, and then I would have, because I have basically 3x, sorry, this will be now 5, okay, 5e to the 4 minus 4e to the 4. That will just be left with e to the 4. Okay, this one was, how was this one? This one was nice?
Okay.
Yeah, okay. I haven't tried this question at all. I mean, I haven't tried any of the questions other than the last one. So we are given the integration of, sorry, we are given the curve with 2 parametrics. Nice. Okay, yeah, I decided I wanted to give you parametrics. Okay, now for anyone doing more practice on parametric integration, there are some really good questions in your textbook, like the mix exercise. Some juicy questions. Please try them.
Yeah.
Okay, so now for this one, let's just give it a quick go. We need to show that the area of R is given by that. So we know the formula of integration for parametric equations. It's not given to you, is it?
No.
No. Okay. So it is basically y with respect to dx over dt, times by dx over dt, dt, like that. Okay. So we are going to do dx over dt, which gives me 1 over t. Okay, and I must actually the limits are between 1 and 2 on the x-axis, right? So I need to get the value of t for that. So make sure we do that, okay? Don't miss out on that, because that's where t1 and t2 are basically missing, okay? So let's do that actually. So when x is equal to 1, ln t is equal to 1, or if you take e of both sides, right, t is equal to just e to the power of 1. And then, so this is your t1 as such, okay? And then when x is equal to 2, ln t is equal to 2, or t is equal to e squared. Okay, so your limits are sorted. It is between e to e squared, okay? And then your y is t plus root t, okay? And then your dx over dt is 1 over t. Nice. This is such a beautiful question. Like, I mean, not beautiful from my perspective, but like nice, like, you know, cute, like simple, easy question. So you just basically split up the fraction now. So t over t is just 1. And then you do square root, like t half minus 1, which will give you t to the power of minus half. And voila, you have your integral in terms of what they wanted us to get. And then we need to just integrate it, okay? Couldn't be easier than this. So I wish I'd taken a harder question, you know, on this and made you suffer. Sorry. Wow. Don't want to make you suffer, but want you to practice, okay? Challenge you, yes. Okay, so now let's just basically finish this off. So when you integrate 1, you get t, okay? And then when you integrate t to the minus half, what do you get?
Minus 2t over minus 3 over 2, 5 over 2.
Minus half plus 1, yes?
Oh yeah, so 3
Yeah.
over 2.
1 over 2.
Yeah.
Dude. Dude.
Authority.
Okay. So it becomes, so it's t to the power of half. So it becomes 2t to the power of half. And then you
Is
simply...
there minus 2?
No, there's no minus.
Because it's a minus, then it's a plus. Minus a half.
Minus a half, but plus 1, it becomes positive half, yes?
Oh,
And you,
yeah,
Smitty, can't go wrong there. Sorry. Okay. And now you just basically plug in the limits, guys. So you would get e squared plus 2, right? Now t is square rooted, so e squared square rooted will give you just e. Okay, so e squared plus 2e, and then minus, you plug in e to the 1. Okay, so just, e. And then you have square root again, so minus 2e to the half. Okay, so, or you can just put it as a square root. So now the final answer is therefore e squared plus e minus 2 square root of e. We are donezo.
I'm gonna do that again.
So this is it, okay, for this session. Practice. Okay, I didn't want to give you super hard questions this time, as I always do.
Next thing will be easier, I think.
We'll see, right? So we'll end the lesson over here.
And then we're gonna get